for Section 2, what roles do species play in ecosystems? The main ideas is to describe how a species fills an ecological niche within the system, and then how do we classify species? We do either as native or non-native, keystone or indicator species. Those are the main things we're going to learn about today, and then understand how threats to the keystone species and the indicator species in turn are going to threaten the whole ecosystem. All right, so what we're talking about now is how do we classify the ecosystems and what happens when something messes with these animals. Okay, if something happens, these animals start to become endangered or extinct, how does that affect the ecosystem? All right. So every animal has its role to play. Remember when we talked about functional diversity a while ago, last chapter? Okay, we talked about species diversity, genetic diversity, and functional diversity. Every organism has its role to play. All right, and so functional diversity was one of the things we were just learning. It was new, it was kind of unknown, mysterious, we didn't quite get it. Here we have a whole section on explaining functional diversity. Okay, so the first thing about species playing a role is their niche. Okay, you can say niche, okay, if you want to be fancy, niche or niche. Just make sure it's not a B and you're not talking about myself. All right, so sorry, just messing with you. All right, so every species has a specific role within the ecosystem it inhabits. Okay, and the ecologists are going to describe that role with that they play as its niche, okay, as its ecological niche or just niche. Okay, that's how they describe the role that that species plays. The niche is its way of life. All right, it includes everything that it needs for survival and reproduction. Because remember, the whole thing about being an animal is if you haven't reproduced, you haven't done anything at all. Okay, you have to be able to reproduce, and so everything that's required to survive and reproduce, like how much water and sunlight it needs, how much space, what it feeds on, and what feeds on it. All right, who are its main hunters? You need to know, and it's a big part of its niche to know who you're running from all the time. Also, the temperature and other conditions, what it can tolerate. That's niche. Okay, but a lot of people get niche and habitat mixed up. All right, habitat is just where it lives, the place or the type of ecosystem that it obtains and where it obtains what it needs. All right, so niche is how the species lives. Habitat is just where. Okay, niche is how it lives. Habitat is just where. Nothing any more fancy than that. Habitat's just minimal. Where does it live? Okay, what kind of ecosystem does it live in? Niche is how does it live? All right, like we talked about on the last slide. All right, and then once we've figured it out, then we're going to go into generalist and specialist. Okay, that's the first breakdown. We're actually going to have 4 breakdowns as far as how the ecologists categorize these species. The first thing is generalist and specialist. Okay, oh, here we go. We got a reminder of habitat and niche one more time. This is a good way. I'm not sure why it's out of order. Sorry about that. So anyway, habitat is the place or part of the ecosystem, all right, that organism lives in. Niche is the role of that organism within the environment. The habitat's a physical place. Niche is a function. It's actually a verb. Okay, where habitat's a noun, niche is a verb, sort of. All right, don't kill me, English majors. All right, and so habitat also reflects just the living place. All right, and niche is the biotic and abiotic association. That means, remember living versus non-living. You remember what abiotic and biotic is. In terms of its diet, its reproduction, and all of its other activities. So niche is much, much, much bigger. Okay, it's the role the ecosystem plays. And everything's a big word, everything that affects its survival and reproduction. Habitat, geographic location. Nothing fancier than that. Okay, and then of course we're going to get to the specialist and generalist. So that part that's under my head, we're covering that right. Generalist and specialist. All right, so An idea of generalist and specialist is like a cardiologist versus a general practitioner. You know, that's what you call just regular doctors, general practitioner. All right, so a cardiologist is a heart doctor, and a general practitioner is just a regular doctor. And specialist versus generalist gets you idea. The cardiologist is a specialist. He specializes in heart. He knows the heart backwards and forwards. He knows all the little ins and outs. He knows every little vessel. He is like king of dealing with your heart. The general practitioner knows how your heart works, and he's pretty good at it. You know, he can give you blood pressure medicine when you need it and all that stuff. But he could also set your arm if you break it. He can treat you for diabetes. He can deliver babies. He can handle skin problems. Okay, he can do all of those things. All right. So he's a generalist, and the cardiologist is a specialist. Where the specialist is super duper duper amazing in his field, he might not be so good at skincare or delivering babies or setting broken bones. He can do it, but he's not very good at it. He's a specialist in your heart. The general practitioner is pretty good with your heart, but he can do a whole bunch of other stuff. That's kind of the idea with the animals, generalist and specialist. Okay, whether you have a narrow niche or a broad niche. Okay, let's see. Okay, so the generalists have a really broad niche, like the raccoon. All right, they can survive anywhere, do anything, eat anything, and they're not really picky. Okay, they can live in many different places, eat a lot of variety of foods, tolerate a wide range of environmental conditions. Some other ones are American crows, coyotes, house sparrows, I believe is behind my head there, and white-tailed deers. All right, all of these guys are generalists. They can make their living just about anywhere, no matter what's going on. All right, let's talk about specialists, though. Specialists have a very narrow niche. They are really, really picky about what they want. All right, only one type of habitat, eat only a few types of food, tolerates a very narrow range of environmental conditions. So you got to think then, why would this be a good thing? Why would any animals, if you can only eat a couple of things, only in a little bit of habitat, only be a narrow range of environmental conditions, why would that be a good thing? Because in that particular environment, you shine. You are amazing. You are the top of getting what you want, doing what you want, having what you want, meeting the right person. You can get your mates. You can do all that stuff. If the environment matches your little situation, you are perfect. You are going to outcompete those generalists. Those generalists can't hold a candle to you in your own environment. Home field advantage, you want to call it that? The generalists can't hold a candle to you in your own environment. However, this is the tricky part. If the environment's changing, all right, generalists win. They're the ones who can figure it out. They're the ones who can sort out and get what they need and make do no matter what kind of situation you have going on. The specialists are so attuned to this particular way of things. They rock, all right? If the world is just like this, they rock. Nobody can outcompete them. They are amazing. But if the world changes, they are up a creek. Okay, that's the difference. All right, so in a stable environment, specialists win. In a changing environment, generalists win. It's a gamble. It's an ecological gamble. All right, so let's look at these shorebirds. It's another example of specialists. Okay, this picture has been used several times. It's in your notes. It's in your book. All right, some of these shorebirds are very specialist species. The only way that you can have this many different types of birds living in this one tiny environment is that each one of them specializes in a different part of the beach. This one gets here, 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 and then they don't have to fight. Being a specialist lowers competition. All right, it lowers competition. You still have to fight with members of your own kind, but you don't have to fight with 900,000 other species. It lowers the competition for you. But the trouble is, if you're going to be that picky, you got extinction breathing down your neck all the time, especially when you have humans in the mix and how bad we are at changing everything's environment all the freaking time. We just said that that is going to knock a specialist out of the ballpark. Right? Only the generalists can deal with changing environments, and humans are really bad about changing environments all the time. So because of those narrow niches that the specialists have, because of those narrow niches, they are really, really prone, meaning it can happen, to becoming endangered when the environmental conditions change. Okay, and like I said, humans are really good at throwing wrenches into all sorts of mechanisms. All right, the giant panda is highly endangered due to the combination of habitat loss and low birth rate and the specialized diet of mainly bamboo. Now, because they are such a specialist, when they lost their bamboo forest, they couldn't eat anything else, or they didn't eat anything else, and the bamboo forest is gone and they started becoming extinct. But you saw on your nose, I'm sorry, that we have a little bit of good news. Because the pandas were so worldwide recognition on the news everywhere, they were able to move them from the endangered list just to highly threatened or vulnerable, highly threatened. All right, so that is good news. We very seldom get good news in ecology and environmental science. I say ecology, I mean the both thing when we're talking about the world. Okay, we very seldom get good news. This is some good news for us, but it's taken a heck of a lot of work. And a lot of people say, oh, I'm sorry, I've been talking the whole time with that thing up. I hope you were able to hear. Hang on a second, stop. No, I'm going to keep going. But some people say that it's a cuteness factor. Because panda bears are cute and cuddly, people want to save them. There's a hog-nosed bat or something ridiculous that looks really ugly. I'm sorry. If it's ugly, people may not want to save it as well. All right, so part of panda's success comes to the fact that he's cute, and that's a shame. Right? That is a shame, but it's how it works. Let's see what's next. Okay, here's another graphic. These graphics are great. All right, so let's see what the generalist says. Semi-prepared for a wide variety of occurrences. They're not really great at any one thing, but they can do a whole bunch of stuff, just enough to survive, and that's all it takes. The specialists are very well prepared for just a few occurrences. All right, the generalists, limited resources spread across a wide variety of options. Means there's a lot of competition, but they can find a little here, little there, little here, little there, tons of competition, but they can get what they need because they're generalists. The specialists, all right, there's a lot less to choose from, but there are less people after it. The competition is lower. All right, then generalist, moderate success for many conditions, limited failure for many conditions. All right, so the losses and gains are moderate. Okay, so they might succeed in a whole bunch of things, they just might, and they just might fail for a whole bunch of things, but that leaves them in the ballpark of doing pretty good most of the time. Now look with the specialist, really, really, really high success in one condition, really, really high failure if that condition changes. All right, so you've got to take where you risk. If you want to risk going up high and being amazing, but then if something happens, you're going to tank it really badly. Or the generalists, which are kind of meh in the middle. Okay, that's exactly what's happening. All right, so when we ask is it better to be a generalist or a specialist, it depends on the environment. If the environment is stable, specialists win. If the environment is changing, generalists are going to win. All right, so the recap, the generalists, they have broad niches, going to eat a wide variety of food, live in a wide variety of environments, and have a lot more competition but are less prone to extinction. The specialists live in narrow niches. They have very specialized diets, live only in a few types of habitats, a lot less competition, but more prone to extinction when the environment changes. Part B, All right, so that first part was habitat and niche and generalist and specialist. Now we're going into this next part, okay? The notes are kind of long, all right? So the ecologist, the next part is, part B has 3 sections: native versus non-native, keystone species, and indicator species. All right, so the first one, native versus non-native, is based on their history within the ecosystem. How long have they been there? Keystone species, these guys maintain healthy ecosystems. They maintain the whole ecosystem, so you'll see what I'm talking about. And the indicator species tell you about the environmental conditions. You hear the word indicator? It indicates how healthy the environment is, and I'm going to go over each of those today. Okay, the first part is native versus non-native, and what you'll see quite often is the word endemic. Endemic also means native, means it comes from that place, native. Okay, so I added it in there. Native and endemic is the same thing. So the native species are those who are naturally originated in a given ecosystem and have become suited to the environmental conditions there. Non-native species are those introduced into an ecosystem which they have not occurred previously. It may be natural occurrences, like a species migrating, might have just migrated into there, or based on human actions, which this is where you get into real horror stories. We have some crazy horror stories for the non-native species. It may be accidental or deliberate. Sometimes we do this crap on purpose and we ruin whole ecosystems. I'll tell you about it. Man, oh man, oh man, we can create some mess. All right, so first, the non-native species. They have several different names. They're also called alien species, and I'm not talking spaceship alien. It just means not from that area. Exotic species, when you want to be nice, or invasive species. Those are the ones that have taken over and disrupted the whole ecosystem. Because they're not always, non-native species are not always bad. It's not a 100% certain that if I say non-native species that it's going to be a bad thing. We have some good ones. All right, but if I say invasive species, those guys have created some mess. Here we go. Good, bad, or indifferent. The non-natives are not always harmful. Here's some examples. Some of the animals and plants that we've grown for food, like tomatoes, those aren't native. Chicken, cattle, fish, a lot of the fish are not native to this area. Okay, but they are certainly doing just fine. They've benefited humans and they're not causing any damage. Okay. So sometimes it's okay, but a lot of times the non-native species are going to compete and disrupt the ecosystem's native species, often causing unintended or unexpected consequences, like the extinction or the threatening, vulnerability, endangering, and extincting native species. If they are bothering the native species, then they are considered invasive. Here's an example. I have like 3 invasive species examples. Okay, you guys have heard of Africanized honeybees. Okay, they will kill you. They attack and kill. All right, but people brought them here on purpose. In 1956, Brazil imported the wild African honeybees to breed with their native honeybees. They were hoping that the African honeybees, when they bred together, the new hybrid would tolerate the conditions better and make more honey. All right, didn't work. Did not work. The opposite happened. The more aggressive honeybees completely displaced Brazil's native honeybee. Completely displaced them. Shoved them out, took over their nest sites. There are hardly any more of the native populations. And the African honeybee makes less honey. And they're mean. Okay, they are crazy mean. They will attack way more viciously than any other. If you are messing in a bee hive, okay, the bees are gonna come back and say, "Get out of my hive! Get out of my hive!" Africanized honeybees will swarm and have known to chase you for like 3/4 of a mile. I mean, you can try to outrun them. Not really gonna work. All right, so the Africanized honeybees have since Brazil, spread across South and Central America, into Mexico, and now into the southern U.S. Texas, Florida, they're having lots of trouble with that. And we keep having to watch, even here in Mississippi coming up into Tennessee, we have to keep an eye on them because they are displacing the local populations. So far, they've killed thousands of domestic animals, cows and pigs and stuff trying to get into the hive, killed thousands of them. And then at least 1,000 people in the Western Hemisphere, they've killed people, about 1,000 people at least. And this was written in 2015, so it's more than that since then. This is just one example of how one example of many that demonstrates how the non-native species can spread rapidly if they find a new location. All right, in their new niches, some of these species will not face any predators. Okay, we have several examples of the boa constrictors in Florida. This is what I've got going on here. People to get boa constrictors for pets. And then the boa constrictor is like too big. The idea of watching him kill a mouse, I mean, just blood everywhere. I mean, it takes a certain amount of person to have a grown snake for a pet. I mean, to watch them feed is just, ugh. Okay, and then what if they have the family has a new baby and the boa constrictor could really easily kill the baby? So a lot of these people, when the snake gets too big, they just put him out. All right, these boa constrictors love the Everglades, Florida Everglades. It's perfect for them. However, there are very few things that can eat them. They are out competing everything. They're all over the place, and yes, they're dangerous snakes. All right, so they can even kill off the alligators, and even if they're not big enough to take an alligator, they'll eat the eggs out of his nest. All right, so we worked so hard to finally get the alligators back in, their numbers back up, that now the boa constrictors are knocking them back down again. All right, and that's just one example. There's many, many. These birds, okay, this is a house sparrow and European starlings. Neither one of them belong here. Both of them come from England. Okay, the house sparrow is one little thing. They brought it to kind of kill bugs. Okay, that was a bad idea. We have plenty of things here that are native that can kill bugs. This European starling thing is freaking ridiculous. Do you know why that's here? That European starling is here because somebody in the 1800s decided that since Shakespeare mentioned starlings in one of his works, that I can't see starlings in my background here in Hoboken, New Jersey. There aren't any starlings in my house. And Shakespeare said there should be starlings. There should be starlings. So he imported starlings from Europe. And they started out competing everything. Native bluebirds, it's one of the ones, now there's not the only thing that they've outcompeted, but bluebirds are one of the most iconic, beautiful American birds. And there are very few left. Very, very few left because of these guys and several others. Okay, but it's just the whole idea of the Shakespeare dude, that's just to ruin a whole ecosystem just because you are snobby. Anyway, but that is another version of invasive species. Okay, so let's go over the details about them, because what's the other word for native? Native is endemic species, the ones who belong there. They originated in the specific ecosystem and they are suited to those conditions. The non-natives, they're immigrants, or they're introduced either on purpose or accidentally into the ecosystem, and they can become invasive. Remember, they're not all bad. All right, but they can become invasive. They'll outcompete or misplace the natives, spread rapidly if they find a favorable niche, and they often lack predators. Whatever used to eat them at home didn't come across the ocean with them. Nothing to eat them now. Kudzu is another one. Man, I think we have that in our discussion day. They brought kudzu. If you've ever been south, driven like south through down like Coldwater and Senatobia, driven down to there's kudzu everywhere. And they brought it on purpose. They brought that stuff on purpose from China. And then it spreads everywhere. They call it the plant that ate the South. All right, here's part two. B2, these are the keystone species. So we're done with native and non-native. These are our keystone species. All right, so that's the second way ecologists classify the species, based on their impact, the impact of their behavior. A keystone species is an organism that plays a unique role in how the ecosystem functions. Without the keystone species, the ecosystem would be dramatically different or cease to exist. Okay, so there's something about a keystone species, an animal, that holds together the whole ecosystem. He's not just in there, he's not just living, he's not just, doing his little thing. The fact that he is there in the ecosystem means that the ecosystem gets to exist. That's pretty powerful stuff. All right, he's not just living his own life. For the simple fact he is there, that's what makes the ecosystem there. Okay, keystone species. All right, now keystone is, you may not have heard that term before. Okay, this is like an arch, like a Roman arch. All right, they would build it from the bottom up, putting their rocks in. They didn't even have to put mortar in here to hold it together. They would just build their rocks. And then if you see, they have this one, they build the rocks all the way up, this one special rock up here on the top. See the way it's shaped like that trapezoid? It holds the arch together. If you take out that keystone, all of those bricks are going to fall in. That's why we call these guys the keystone species. Okay. So a keystone species is going to play several critical roles to help maintain ecosystems. For example, the mountain lions and wolves control the distribution and populations of prey animals like deer and rabbits by influencing where these species feed and raise their young. Most of the keystone species, not all of them mind you, but a lot of the keystone species are predators in their ecosystem that keep the mid-level predators. Remember, we learned our food pyramid, the ecosystem, the energy pyramids, right? Where you have the grasses on the bottom, then herbivores, omnivores, carnivores, and the apex predators on top. Well, if you take out the apex predator, there are still some predators here on these second levels. All right, but without the apex predator, these mid-level predators will eat up the whole ecosystem because the apex predator has to keep their numbers in line. All right, so that's one of the main things they do. They will keep the population of prey animals down by influencing where they feed and raise their young. We saw the video how wolves change rivers, right? It was amazing, the simple fact that they thought all the trees were going down. Which ones was it? Aspen trees. The aspen trees were gone. Remember we watched that? The aspen trees were gone. And the whole reason they were gone is because the wolves were gone. Now hang on. Wolves don't eat aspen. How is it that because the wolves were gone, the aspen, it's a tree, a gorgeous tree, the aspen were gone? Because the wolves ate the deer. And without wolves to chase them, okay, the deers would just sit and eat and eat and eat and eat and eat all day. And they ate up the whole riverbanks. All right, and then the erosion and crap, because the trees and stuff were gone, because the deer were just standing there being all lazy, stuffing their faces the whole time. When they reintroduced wolves to the park, I'm talking Yellowstone, when they reintroduced wolves to the park, the wolves kept the deer moving, right? Because pretty quickly, if the deer stand still too long, wolves are going to come get them. So because the wolves were there eating some of the deer and keeping them moving, the aspens could grow back. And of course, once you have a wolf kill, the wolves aren't going to eat every single scrap. So you also have scraps left for the scavengers, right? You have a lot of the birds are scavengers, some of the mid-level animals are scavengers, and then once that deer, the wolf kill, the deer decomposes into the ground, all of a sudden you've got all these nutrients. All right, so it turned out that we had killed off and taken all of the wolves out of the park, Yellowstone, because we were afraid of them. But it turns out that the wolves had a very, very important role in keeping the beauty of what Yellowstone was. Letting them back in helped it fix. Okay, keystone species. Okay, sea otters is another one. What sea otters do is they eat, you see these little purple things down here? They eat these sea urchins. It's one of their favorite things to eat. All right. They killed a whole bunch of sea otters for their fur because, they're waterproof, right? Back when people wore fur coats, they couldn't just go to Walmart and just get them a down comforter coat or whatever you call that. They had to wear fur coats in the wintertime. That was their only choice. An otter coat was amazing for snowy, nasty environments because it was waterproof. So they killed a whole bunch of them for coats. All right, but now, you see these urchins down here? They don't just eat a little bit of the kelp. They don't eat this top part of the kelp. They eat the bottom part of the kelp. And so the kelp was dying. So this whole forest where seals would live, fish would live, seahorses would live, tons of different things would live here in this kelp forest. These urchins killed it all. They ate the whole thing to nothing. They called them urchin barrens because all the plants were gone. And of course, any animal that wanted to live here couldn't. All right, so otters are a keystone species. Sharks are a keystone species. Now, we know that sharks, we want to think, oh, donut, 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 Jaws is going to get you. No. A lot of that's really, really exaggerated. It makes fun movies, but it's really, really exaggerated. And if you get rid of the shark population, these mid-level predators are going to increase, and they are going to kill off all the herbivores. All right? And then you have algae overgrowing the corals, and then things are a mess. All right? It's horrible. So we didn't even realize this is something new that we're learning. Without your keystone species, the ecosystem falls apart. The sharks, and then we talked about the American alligator. Now, the American alligator, we talked about the boas taking their place when we talked about invasive species, but alligators have this amazing effect on the Everglades. They can smell water. You know it's really hot in Florida, right? The land is full of clay and spear grass, and it's just really, really hard grass and the clay soil, but alligators can smell water. And what they will do is they will go through and they'll try to find a place. I'm sorry. Okay. They'll find a place where the water is near the surface. And they will dig and dig because it's hot in the summertime in Florida. They'll dig and dig and dig till they can get to the water. And then some of the water kind of bubbles up out of the clay. And they'll keep digging and they'll make it comfy and nice for themselves. And they'll, at the side of the bank, they'll dig themselves a hole here on the side. The water is down here. And they'll dig themselves a hole for the winter time. They'll kind of just hide up in there. All right. But once they've dug this hole so that they can get to the water so that they can cool off, now all of a sudden you have fresh water for everybody because he dug it up out of the ground. You have nesting and feeding sites for the birds and all the other animals. This digging activity maintains the balance of vegetation. I told you that spear grass is horrendous stuff to walk on. The cows can't hardly eat it. Most of the animals don't like it. But when the alligator clears out that gator hole, it allows other grasses to come in. All right, and it also helps to control the predatory fish populations because the alligators are going to eat the bigger of the fish. That gives the smaller of the fish chance. All right. If the too many of the predatory fish, like I said, just with the sharks, right? The alligator is going to eat up the mid-level predators so that the herbivores and the bottom levels can continue to grow. They were hunted almost to extinction, and now they finally got them back off the endangered list in the 80s, and now all of a sudden there's boa constrictors everywhere. Those pythons. All right, so this is a graphic. This is in your notes. You can go through it yourself about how the alligator maintains. Here's his little place where he hides. Okay, he digs this out and he hides in the wintertime. But he smelled the water beneath the surface and he dug this himself. And then everybody gets to make use of his gator hole. Now with sharks, part of the problem that we're losing so many sharks, we already showed you the picture of that, but over 1 million are killed annually in response to exaggerated media reports. People, you see the whole Shark Week on Discovery Channel. People kill them because they're scared. All right, over 1 million people are killed from that, but 1 million sharks are killed because people are afraid. But the worst thing is
finning. Finning. It's a thing that they do for soup. Shark fin soup is a delicacy, and they will kill sharks and leave them there. Okay, did I put this picture in? I didn't, but I think it's in your notes. These sharks are just, you drop their fins off and they just leave them in the water. It's horrendous. It's horrendous what they do when they're finning these sharks. Okay, so the keystone species in general, and all of these examples I've talked about, the sharks, the wolves, the otters. Okay, I didn't mention the mountain lions, but they're too close to extinction to really have a good example for us. But the sharks, the otters, the mountain lion, wolves, sharks, otters, wolves are examples of some of the keystone species. But that's not all. It's not always predators. Beavers are also a keystone species. You know how beavers, when they build their dam, they can change their whole ecosystem. So it's not always predators, but it is quite often. All right, keeping the populations in check. So the keystone species affect the type and abundance of the other species in the ecosystem. The ecosystem would be dramatically different if the keystone species disappeared. Part of the thing they do is regulate the population of the others, like I said, keeping the mid-level predators in check. And if you get rid of them, you might cause population crashes and extinctions of the other species that are dependent on him. You get rid of the wolves, the other things, like I said, the aspen trees. We couldn't figure out why the heck we're losing aspen trees. You get rid of the keystone species, the other species suffer. All right, last one, the indicator species. All right, that's an indicator. His name tells you what he does. Okay, he's not hard. Indicator species indicates by his presence or his absence. Okay, if you have them there, you may have a trouble. If they're gone, you may have a trouble, depending on what you're talking about. But it indicates the conditions of your ecosystem. Okay, and they're called indicator species because they indicate. All right, so they're the presence or absence of these indicator species will tell you the qualities or characteristics of environmental conditions. They serve as an early warning system. For example, some of them can be indicators for levels of air pollution, or they could be sensitive to environmental changes that will be affected almost immediately by damage to the ecosystems. Frogs are a very good example of an indicator species. All right, if you have frogs in your ecosystem, you have a healthy ecosystem. This is why we use them. Do you remember the case study where the lady was studying the frogs at the beginning of the chapter? All right, frogs are an indicator species. If you because their skin is moist and they breathe through their skin, okay, if there's pollution or damage to the environment, they're going to know. It's going to make them sick. They're going to die. If they have a chance, they'll leave, but most likely they're going to die. And so if you had an ecosystem that had tons of frogs in it, then all of a sudden all the frogs are gone, something happened to your ecosystem. They're an indicator species. They indicate that the environmental conditions are deteriorating. Okay? They serve as a biological smoke alarm. All right, so the indicator species are very sensitive to changes in the ecosystems. Their presence or absence will indicate the quality of the characteristics. Our case study, like I said at the beginning, the frogs are very good indicator species. They can show natural environmental factors, virus, fungal disease, and parasites. You can't see this behind my head, but it's in your book. This frog has way too many legs. It's gross. He's got way too many legs. But in his ecosystem, there was a parasite. All right, that is a really interesting study in itself. It's kind of gross and yucky, but it's a really cool study that we might talk about one time. All right, but the frogs with too many legs because of a parasite. But they can also show and indicate human-related factors like habitat loss, pollution, and climate change. Again, indicator species indicate the characteristics of your environment. All right, now we have this statement. No organism exists in isolation. All right, because, okay, how does this relate to the lesson content? Because every single organism will affect every other, no matter what, especially humans, but all of the different species will affect how the other species in their ecosystem work. So first off, let's double check to make sure we understand. Here's our 4 main parts. Do you know the difference between niche and habitat? Do you know the difference between generalist and specialist? Do you know the difference between endemic and non-native species? Do you know the difference between keystone and indicator species? If you can answer yes and you got details, you're good. If not, you might want to rewatch some of this because this is the key for the chapter. So here's our section summary. So every species plays a specific role in its niche. Within the niche are species classified as generalists or specialists, and within the ecosystems they can be further classified as native or non-native, keystone or indicator. Next up, we have our native or endemic species are those that naturally originated in the given ecosystem, have become adapted to those environmental conditions, and the non-native species are those that are introduced to or migrate to the ecosystem that they did not occur previously. The keystone species play critical roles in sustaining their ecosystem. The loss of them can lead to population crashes and extinction of the other species. The indicator species are those whose presence or absence indicates a certain quality of the environment. And we got it all. All right. All right. I'll see you the next time, everybody. Bye.